everyone. Thank you very much for signing in and watching my live stream. I'm Mr. Matt, and this is Dr. Tot. Dr. Tot, cookie for class? You want a cookie? Oh, yes. And welcome to Algebra I. This week and next week, we're going to be spending the Monday through Friday slots entirely devoted to preparing for the Semester A exam coming up. And what I've done is I've broken the semester into 10 components, and we're going to go through the clusters that I've made in each of these live streams. And I want you to use these live streams along with the practice exam that will be linked below in the description and available to you soon as diagnostic tools. These are in no way a substitute for your own teacher's review packets, but they're to supplement the resources that you have and provide some solution videos for you. If you find any exercises in this or any other live stream that you feel a little bit uncomfortable with or you'd like to see more examples of, you can look into the description, and each one of these live streams will have a corresponding independent practice set as well as a quick drill set A and a quick drill set B. The independent practice set is going to be a larger exercise with many different examples at various difficulty levels. The quick drill sets A and B are going to be shorter activities, but they're going to be more difficult and concentrating on word and real life scenarios wherever possible. If you have any questions at any point, please feel free to drop a comment below, and I'm also available on any of my social media accounts that are listed in the description. So feel free to reach out, ask me a question. If you have any recommendations on a video, any topic that you don't see a video for or I haven't covered yet, please let me know. With no other ado, let me go ahead and share my screen with you. Just a reminder, these are live sessions, so there is a little bit of a delay with the iPad, and I'm going to mitigate that as much as possible. So let's go through a few examples here. In this session, we're going to be concentrating on understanding the difference between direct and inverse variation. We're going to look at some speed and time, distance questions, as well as calculating the constant of variation for those direct and inverse variation questions. This document will be posted on Certified Learning Center's website. There will be a link in the description. Just make sure that you're looking at the document that has this unique reference number on it, 1949-4. That way you know that you're in the right place. If you're watching live, it isn't currently posted, but it will be posted very shortly. Okay, let's look at number 1. I'm going to give you 3 minutes. After the first minute, or 1 minute into that time allotment, I'll start to solve in order to give everybody some hints if you need some hints. If you have any questions at any point, feel free to ask. Otherwise, question number 1 asks, calculate the value of the missing variable and determine the constant of variation. So this is testing direct versus indirect variation. A asks, x varies directly with y. If x is 10 when y is 20, what is the value of x when y is 80? B asks, x varies inversely with y. If x is 30 when y is 5, what is the value of y when x is 15? So I'll give you 3 minutes. Again, 1 minute in, I'll start to solve. And after the first problem in these sets, I'll go through a full explanation of the solution. So 3 minutes, give it your best, and then we'll go through the full solution. Okay, so let's talk about this. So variation, what that means, if something directly varies with something else, that means as one thing increases, the other increases by the same percentage or the same percentage change. Or conversely, as one decreases, the other decreases. So they go hand in hand. If one increases, the other increases by the same percentage. If one decreases, the other decreases by the same percentage. That can be represented with this formula, x divided by y is equal to k. K represents the constant of variation. It represents the value that this ratio always has to represent. Now, this makes sense because if you see, if these values are dividing into each other, if I increase x, I have to increase y by the same percentage in order to keep k the same number. Because remember, k is a constant. It can't change at all. So if I increase x, I have to increase y in order to make that, by the same percentage, by the way, in order to keep that k the same. K, it's just an arbitrary, randomly chosen variable that represents a value that never changes. It represents the constant of variation. Keyword there, constant. Inverse variation is the opposite. As one increases, the other decreases by the same percentage. If one increases by 30%, the other thing is going to decrease by 30%. Or vice versa. If one decreases, the other increases. So they go in opposite directions, but by the same percentage change. Direct variation goes in the same direction by the same percentage change. Inverse variation can be represented by the formula x times y is equal to some constant value. So what you want to do is you basically, in order to solve these variation problems, is you end up, first you have to identify which formula you should be using dependent on whether it's direct variation or inverse variation. And then you're going to use that formula twice. Once in order to calculate the constant of variation, then the second time in order to use that constant, because the constant can't change, it's a constant, to use that constant in the second equation in order to solve for the missing variable that the question asks about. So here, for question 1a, x varies directly with y, and x is 10 when y is 20. What is the value of x when y is 80? So I did a in the red ink to the right. They say that it varies directly, so I know that immediately that I'm using the formula x over y is equal to some constant. I'm going to substitute in the given values for x and y. They say x is 10 when y is 20. So I'm going to have 10 over 20 is equal to the constant. 10 over 20 reduces to 1/2. So the constant of variation here is 1/2 for question 1a. Now, that's one part of the question, but I need to actually solve for what x is. So I'm going to set up the formula again. Now I'm going to use the missing variable, or the variable to represent the missing number, x, and I'm going to insert the new number for y and the constant that I solved for in the previous step. So that turns into x over 80 is equal to the constant of variation of 1/2. Solving for x, I just need to multiply both sides by 80. 1/2 times 80 is 40. So the answer to number 1a, x would be 40 when y is 80, and the constant of variation is going to be 1/2. For 1b, if x varies inversely with y, x varies inversely with y. If x is 30 when y is 5, what's the value of y when x is 15? So if it varies inversely, then immediately I know that I'm using the formula x times y is equal to k. So I'm going to use that twice. Once to establish the constant of variation, the second time to solve for the missing variable here, it's y. So they say that x is 30 when y is 5. So 30 times 5 is equal to the constant of variation. 30 times 5 is 150. Now I can rewrite that formula again. leaving y unknown and inserting the new value for x as 15. So then we get 15 times y is equal to 150. Solving for y, I divide by 15, and y would be equal to 10. So 1b, y is equal to 10, and the constant of variation would be 150. If you have any questions, then please let me know. Otherwise, let's look at the second problem here. So this is going to go into some speed, distance, and time word problems. So I want you to calculate the missing speed, distance, or time. And I gave you the formula for speed. Remember though, this is the easiest one to remember because if you think about your most common unit of speed, so either miles per hour or kilometers per hour, notice what are miles or kilometers? It's distance. In math, the word per means division, and hours is a unit of time. So speed, kilometers per hour, miles per hour, that's distance divided by time. So if you think about your most commonly used unit of speed, you can remember that the formula for speed is just distance divided by time. You can manipulate this formula to get the other three variations. Notice I could multiply by time on both sides, and that would tell me that distance is equal to speed times time. And then from there, I could divide by speed, and that will tell me that time is equal to distance divided by speed. So these are three variations that you can render from just remembering your most commonly used unit of speed. Usually that's miles per hour or kilometers per hour. Okay, I'm going to give you 3 minutes. Go ahead and look at 2A, B, and C. 1 minute in, I'll start to solve, and then we'll go through all of them. Okay, so for number 2, A, B, and C were testing, they're asking us to calculate either the speed, distance, or time that Ricardo took in his driving his car. So for A, Ricardo drove his car 40 miles in 1.25 hours. What was his average speed in miles per hour? So one thing that you really have to look out for, if they want to be tricky, they can change units. If they gave you the amount of time that he drove his car in terms of minutes and then asked for a speed in terms of miles per hour, you would have to make sure that you compensated for those difference in units by converting one to the other to make sure that you're working with common units. We will get some exposure to that. For here, you're all good. You have miles and you have hours, so, and then they're asking for miles per hour, so everything matches up. But I just wanted to make you aware of that, that if the units are different, then you really have to watch out because you have to use common units. So speed is equal to distance divided by time. Remember, think miles per hour. Per in math usually denotes division. So distance divided by time is equal to speed. He went 40 miles in 1.25 hours. So 40 divided by 1.25 is going to give you a speed of 32 miles per hour. For 2B, he drove his car 30 miles at an average speed of 60 miles per hour. How many hours did he spend driving? Well, time is equal to distance divided by speed. So the distance here was 30 miles. His speed was 60 miles per hour. So 30 divided by 60 is going to be 1/2 hour. And 2C, if Ricardo drove his car for 4.5 hours at an average speed of 40 miles per hour, how many miles did he travel? Distance is equal to speed times time. So his speed here of 40 miles per hour times his time spent traveling of 4.5 hours is going to give you a total of 180 miles. Again, if you have any questions, then please let me know. Otherwise, let's look at question 3, and this is going to go back to direct versus indirect variation, direct versus inverse variation. So I'm going to give you 3 minutes. They're asking you to calculate the value of the missing variable and determine the constant of variation. A is saying, question A says, the variable A varies directly with the variable B. If A is 50 when B is 75, then what is the value of B when A is 125? Question B asks, the variable A varies inversely with the variable B. If A is 60 when B is 12, what is the value of A when B is 36? So I'll give you 3 minutes, and 1 minute in, I'll start to solve. Okay, so let's talk about number 3. So if 3a, if we're talking about direct variation, that's going to be given from the formula 1 divided by the other is equal to the constant. So here we're using the variables a and b rather than x and y, but that's okay, it doesn't make any difference. So a divided by b, or a over b, is equal to some constant k. They say that a is 50 when b is 75, so we know that 50 over 75 is equal to k. Both the numerator and denominator are divisible by 25, so that's going to reduce down to 2/3. So if the constant of variation is equal to 2/3, I can set that constant equal to the new value of a over the unknown value of b. In order to solve there, however, I needed to cross multiply. Anytime that you have two fractions on opposite sides of an equal sign, you can cross multiply, so that left me with 2 times b is equal to 3 times 125. So that gave me 2b is equal to 375. It's really important to recognize that you can only do cross multiplication when the fractions are on opposite sides of an equal sign, so when there's an equal sign between them. If the two fractions are just next to each other, that's just simple multiplication of fractions. That's just straight across, numerator times numerator over denominator times denominator. Here, though, they're on alternate sides of an equal sign, so we can cross multiply. Dividing by 2 will give us b is equal to 187.5. Now for 3b, a varies inversely with b, so now we're using the formula a times b is equal to some constant of variation. They say that a is 60 when b is 12, so 60 times 12 is equal to the constant. 60 times 12 is 720, so now I can reset the formula with the new value of b, and I can say that a times 36 is equal to 720. Dividing by 36 on both sides will give me a is equal to 20. So the constant of variation for 3b was 720, and a would be 20 when b is 36. If you have any questions, then please let me know. Otherwise, let's look at number 4. So number 4 is going to be another speed, distance, and time problem. Question A asks, Roxana drove her motorcycle 100 miles in 2.75 hours. What was her average speed in miles per hour? Question B asks, Roxana drove her motorcycle 165 miles at an average speed of 30 miles per hour. How many hours did she spend traveling? And C asks, Roxana drove her motorcycle for 120 minutes at an average speed of 50 miles per hour. How many miles did she travel? Remember the hint that I told you that you have to have common units. So watch out if they give you a time period in terms of minutes, for example, but they ask you for a speed in terms of hours. That's problematic. You're going to want to convert before you use that value. So you want to convert minutes to hours if they're asking you for miles per hour. Okay, I'll give you 3 minutes and then we'll go through the entire solution. After 1 minute, I'll start to solve. Okay, so for number 4, remember you can use, if you remember your most commonly used unit of speed, usually when you're driving in a car, right? Either miles per hour or kilometers per hour. Miles and kilometers are units of distance. Hours are units of time. So your speed of miles per hour or kilometers per hour will let you memorize or allow you to memorize that speed formula. It's distance, miles or kilometers, per divided by time, hours. So if you know that speed is equal to distance divided by time, you can solve for the other two variants. Multiplying by t, you get distance is equal to speed times time. And then dividing by speed, you would find that time is equal to distance divided by speed. So for 4a, they give you distance and they give you time and they ask you for speed. So if she goes 100 miles in 2.75 hours, 100 divided by 2.75 is going to be 36.36 bar. In mathematics, when we say bar, and we literally write the bar over the decimal point, that means that those values repeat infinitely. So that 36 keeps on going on. So that literally, in your calculator, would be 36.36363636, so on and so forth. So that's your answer to 4A. 4B, if she drove her motorcycle 165 miles at an average speed of 30 miles per hour, then time is equal to distance divided by speed. So we're going to take 165 divided by 30 miles per hour, and we're going to get 5.5 miles. There's going to be hours. And for C, if Roxana drove her motorcycle for 120 minutes, notice the minutes there, at an average speed of 50 miles per hour, how many miles did she travel? Your speed is in terms of miles per hour, and your time is in terms of minutes. So the first thing that you need to do, as I did in purple there, is you need to convert 120 minutes into hours. Take the 120 minutes as a given explicit value. If it's not a fraction, which it's not, you can write it as a fraction by just putting it under 1, putting it over 1 rather, and then multiplying by some equivalent, some conversion rate that will transform hours to minutes. So for example, how many minutes are in an hour? 60. I have minutes in the numerator, so I want to make sure that there's minutes in the denominator in order to cancel. So I'm going to multiply 120 minutes by 1 hour over 60 minutes. Minutes cancels with minutes, and now I'm left with 120 hours divided by 60. Well, 120 divided by 60 is 2. So she traveled for a total of 2 hours. So now I can go back to my formula for distance. Distance is equal to speed times time. So the speed of 50 miles per hour times the 2 hours she traveled means that she must have driven 100 miles. If you have any questions, then please let me know. Oops, sorry about that. Minimize my screen there. Let's go ahead and look at question number 5. So please calculate the value of the missing variable and determine the constant of variation. So h varies directly with g. If h is 25 when g is 125, then what is the value of g when h is 75? 5b asks h varies inversely with g. If h is 800 when g is 600, what is the value of h when g is 1000? I'll give you 3 minutes. After 1 minute, I'll start to solve. Okay, so number 5, if h varies directly with g, and if h is 25 when g is 125, what is the value of g when h is 75? So if we have direct variation, then we're using the formula h over g is equal to some constant k. Substituting our given values for h and g, we're going to get 25 over 125 is equal to k. Both of those are divisible by 25, leaving us with a simplified fraction of 1/5. So our constant of variation for 5a is 1/5. Substituting that into a new iteration of that formula, using the new value for h, we're going to get 75 over the unknown value of g is equal to 1/5. You can cross multiply there and get 75 times 5 is equal to 1 times g. So g is equal to 5 times 75, which is going to be 375. 5b, h times, well, if it varies inversely, if h varies inversely with g, we're using the formula h times g is going to be equal to some constant of variation. They say that h is 800 when g is 600, so we can write the equation 800 times 600 is equal to the constant. So the constant is going to be equal to 480,000. Now we can use that constant in the new iteration of the formula with the new value of g. So we're going to have h times 1,000, which is the new value of g, is equal to 480,000. Dividing by 1,000, you're going to find that h is equal to 480. So the constant of variation is 480,000, and the value of h when g is 1,000 is 480. If you have any questions, then please let me know. We're going to do one more example, and this will bring us up to the end of class today, and I'm going to try and make sure that we get through all of it. So go ahead and I'll give you 3 minutes. Calculate the missing speed, distance, and time of the following 3 scenarios. Tony drove her car 150 miles in 180 minutes. What was her average speed in miles per hour? B asked Tony drove her car 200 miles at an average speed of 20 miles per hour. How many hours did she spend traveling? And C asked Tony drove her car for 6.75 hours at an average speed of 45 miles per hour. How many miles did she travel? Okay, so for number 6, 6A, they give us distance and they give us time, but they give us the time in terms of minutes, and they ultimately ask for the speed to be calculated in terms of miles per hour. So the first thing I'm going to do is convert that 180 minutes into hours by multiplying by 1 hour over 60 minutes. Notice when I do that, minutes cancel with minutes, leaving me with a unit of hours. And that's exactly what I want. So you can use the units to your advantage to understand whether you executed the correct mathematical process or not. So she's traveling for a total of 3 hours, and she went 150 miles. So we want to calculate the speed here, which is going to be distance divided by time. So 150 miles divided by 3 hours is going to be 50 miles per hour. For 6B, if she drove 200 miles at an average speed of 20 miles per hour, time is equal to distance divided by speed. So if we take the 200 miles and divide it by the 20 miles per hour, notice that miles and miles match up, so that's okay. If for some reason they had miles and feet, we know that we have to convert first. You have to use common units. But 200 divided by 20 is going to be a total of 10 traveling hours. And lastly, 6C, if she drove for 6.75 hours at an average speed of 45 miles per hour, then distance is equal to speed times time. So we're going to take 45 miles per hour times 6.75 hours and get a total of 303.75 miles. If you have any questions at all on anything that I've done today, then please let me know either in the comment section below, or you can get a hold of me on my social media accounts that are listed in the description. If you found anything troubling in today's lesson, in the next few days I'll be putting out an independent practice problem set as well as 2 quick drill sets on related topics. So make sure that you watch those. And if you have any recommendations on something that is really troubling you, then please reach out. I'm always here for you. Thank you guys very much for watching. If you find these videos helpful, then please like and subscribe and share with your friends. But otherwise, Tater Tot, you want to say goodbye? Come on, Dr. Tot, you say bye to everybody? Come on. Can you say bye? Sit. Can you say bye? Bye? Very good. Very good, boy. All right, thank you guys very much for watching. I hope you have a wonderful night, and I will talk to you all tomorrow.